I'm Danny Abramovich from the IEEE Control System Society History Committee. Today we're interviewing Abraham Haddad, who has a long history of involvement with Control System Society and A squared C squared. Thanks for being with us. Wanted to ask you to start out about sort of your background, really where you grew up and early influences.
Well, I got my degrees at Technion in Israel Institute of Technology, and then a PhD and master's at Princeton University. I was really in the communications area, but an area was at the interface between control and communications, filtering and estimation detection problems. So when I moved after Princeton, moved to the University of Illinois at Urbana, the communication group was very deterministic, and I figured it was easier to work with the control group, since it was really more broader in its outlook and interest, and that's how I got involved in control. My research at the time was dealing with estimation detection problem involving, for example, military system, maneuvering vehicles, and so on. So it really was an element of control, and I continued to work in that area during my tenure at Urbana-Champaign.
Okay. Who's your advisor?
My advisor was John Thomas, and he has quite a few famous students, including Gene Wang, who was dean at the University of California, Berkeley. He's chairman, not dean, but chairman. And he was also in the science advisor to the president. He was in the office of the science advisor. I don't remember exactly what it was.
So, but he was more communications theory.
Yeah, well, stochastic system, stochastic processes. He and Zakai had a lot of work together, and Zakai, as you know, received the Control Systems Award a few years ago in 93. In 93, yeah.
You chose academia when you got out of graduate school. Why that choice?
Academia was more interesting, more freedom to do whatever you want to do in terms of research, provided you can get support for it. Industry at the time, the only industry that was interested at the time was Bell Labs and maybe IBM or Crown Heights. But the process was a lot longer. So when I received an offer from Urbana, which was very highly ranked at the time, was something you really want to go to.
So then, since then, you've been to a lot of different universities.
Yeah, I've been to a lot of places. Urbana was great research-wise. It was a good place even to start a family and raise children, but not a good place to permanently to be there, simply because it's just there's not much for spouses to do, and so we looked to leave the place after about 12 and a half years. And since then, we had quite a lot of experiences. We spent about 9 months in a small research company in Massachusetts Dynamics Research Corporation, and spent 4 years at the National Science Foundation, 5 years at Georgia Tech, and almost 14 years at Northwestern University.
You had a stint at Tel Aviv University.
That was a sabbatical. I was a sabbatical at Tel Aviv, and also recently I had sabbatical, which involved 4 different universities, including Tel Aviv, the University in London, Newcastle in Australia, and Canterbury University in New Zealand.
So I remember my father telling me that Israeli universities being a very continental European type system of research. The structure of how it was run.
The structure of research is more European, but in terms of promotion and tenure processes, they're very try to follow the American example, and since they really ask for a lot of letters and make sure the person is really doing good research and ask for external letters quite heavily. And their research is supported primarily by the government, so it's really more like 12 months kind of job rather than 9 months plus academic plus summer support.
So, do you think Northwestern is where you will be retired from?
Yeah, I'm old enough really not to move around anymore. Northwestern has been a very good place. It is private university, the only private university in the Big Ten, and it's really has a lot of ability to collab for interdisciplinary collaboration with other part of either both the college and other university departments.
Switching to sort of big events in your career, can you tell us about any large influences on your career, whether people or events that had a strong effect on your choices and what you did?
Well, my advisor, John Thomas, of course, was a very strong influence on which direction to follow and how to deal with an academic position. He's really very good at preparing you for university work in the sense that he does advise you of not just finish the thesis and end, look at the thesis at the beginning rather than ending. And Urbana had a strong influences from people like Joe Cruz, who was at the time very highly involved with the Control Systems Society, and people like Mike von Wackenberg, who was one of the leader in the area of circuits and systems and so on in the Champaign.
Were there any specific events that sort of things where, whether technical events or global events that made it sort of, I should turn my work this way?
Not that I can think of, really. It was more like a continuum kind of things. There's no really major milestone that leads to one way or the other.
I'm curious, when we do these history things, we're always curious about the stories that people have to tell about. Do you have any favorite stories from your long career and all the places you've been and people you've interacted with?
Oh, this is a tough one. You didn't prepare me for that.
Sorry. We can come back to this.
Well, the thing that really sticks to mind, and I don't know call it a story, but one of the highlights was I organized a CDC in Las Vegas, and that was the first CDC that were held in Las Vegas. And at the time, when I approached the society to have this, they agreed to do it because it's come from, I was in NSF, they said, well, if the government thinks it's okay, because they're afraid it might be considered boondoggle. Mm-hmm. So we had a beautiful suite with mirrors and so on. And that was very interesting for people to come and look. I did have a running with the IEEE hierarchy when the program had sort of a dancing girl on the cover, and it was not considered appropriate. So the cover of the proceedings, we had the Hoover Dam instead.
About your work, is there one piece of work that you've done that is like your favorite piece of work or period of time, something that you're working on that stands out in your mind?
Mostly, it's really a lot of little things rather than one big event. Primarily, I try to really relate to work applications. So when I was in Illinois, I used to consult a great deal for the military, with the Army Missile Command, and we had really interesting work, application, tracking and so on to missile guidance. And later on, as Georgia Tech, we followed that with doing work on, and again, with the Air Force at the time, with moving vehicles. More recently, actually, we are working with a few colleagues on interesting problem with communication networks, because of the work in networks, many of the communication systems people who deal with they use ad hoc techniques, and it's very little attention to what is involved in feedback. And now I see a lot more interaction in this regard. For example, there is a small group, a nice group at Urbana working in this area, same area, similar area. So that's really, I think, now it's really very interesting to work on problems that are really important to try to improve quality of service and communication networks and reduce congestion and so on.
During your time, I mean, the list of awards that you've been given are quite spectacular. I want to ask you about this IEEE Centennial Award, which we were given in 1984, and Control Systems Society Distinguished Member Award in 1985, and then most recently the IEEE Third Millennium Award. Can you fill us in on the events surrounding them?
Well, these are awards that were given for service at the time. You know, if you were at the, for example, the Centennial Medal was given when for the key people who were active in the Control Society at the time. At the time, I was editor of the transactions of automatic control. I was at the time I served the longest serving editor of the transaction, except for the founding editor, which is actually, of course, John Baby will beat my record, and now I think Sandra is beating his record as well.
And one of the questions that we were recruiting questions with you, people wanted to know what is your power source? How do you keep going so active?
I have a lot of energy. I don't know where it's come from, and I really wake up very early with the sun, so it's really, I can't really sit still if you see that. The same thing happens to my children the same way. They can't, they always constantly have to be in motion. So, and that's really what I like to do, a lot of things for society, in addition for university and for research and so on. Otherwise, it gets very boring to do the same thing over and over again. I like to do variety.
I'd like to switch over to your involvement with Control System Society and the A squared, C squared, because I know as long as I've been involved in control, you've been involved with running the A squared, C squared. Can you fill us in? How did you first get involved with?
Well, first I started with the Control Society, and I was appointed associate editor in '76, which is about 26 years ago, and I found that very interesting. Was associate editor at the time. The work with the control with the transaction was very extensive because there were very few associate editor, and you used to decide on the papers on meetings that met 3 times a year, the editorial board, and that was quite time consuming and required really very careful planning to attend that. And you cannot just you got the reviews and so on. You have time to make sure the reviews arrive on time. At the time, Steve Kahn was editor, and he really was a very big supporter of people who do a good job. So and many times when he was in a higher position, he would always ask me if I want to serve on this or that. And it's very difficult for me to say no to him because he's always been very supportive. After that, when I left Urbana, I went to Dynamic Research Corporation. NSF position was open, so Steve and other colleagues asked me if I want to apply to the NSF job. So at NSF, that was really a very way of getting involved. I was more involved with the society than before because the program I was directing, System Theory and Operation Research, has a really bigger component of the Control Systems Society. And that got me more involved with the society. I became, I was secretary of the BOG or secretary administrator, whatever the title was at the time. I also served as chairman of the publication committee. Followed that, when Mike Sain stepped down from editorship, they told me I was the first to contact to serve as editor. And of course, that was a position that really the plum, in the sense you think of the premier journal of control at the time. There were no other. The control system technology wasn't out yet. Automatic was the only competition we had. The control engineering practice wasn't yet out, wasn't yet started. So it really was something you cannot really say no to. And starting with that, of course, I kept my hand with other things as well. For example, organizing a CDC in Las Vegas in '84. So when Bill Miller, and of course, I always being in the Control Society, we attended both meetings, both ACC and CDC. So when in 88, I guess, Bill Miller expressed his intention of retiring as secretary of the AACC, I was approached by several people from the society, Bill Powers and Steve Kahn. Bill Powers was president at the time, the AACC service secretary, and then promised me, well, this would be just until the IFAC Congress, which was in '96. But once you get into this, it really becomes addictive because you have so many things you need to do, and you really want to make sure that things keep running smoothly. So, and really, this is with the way I see it, I like to make sure things run well. I don't care about titles, so I prefer to be a secretary of that organization than its president, because you want to do things rather than worry about the limelight. And I think this is, I'm coming to the end of my term as secretary of the AACC. By the way, during that time, I also was president of the Control Systems Society at one time. And also at the same time, I also was running the 93 American Control Conference. So quite interesting period. There's a lot of things happening, and we're undergoing at the same time program review of my department. I was chairman of the department at the same time.
That's very nice. Yes, no, your power session. So, can you tell us any stories from the early days, like the Control Systems Society, the history of it? As you know it.
Yeah, I wasn't there at the creation, so to speak. It's people like Joe Cruz and John Zaborski were. But I was there early enough that I was aware of all that was going on, for example, and the structure and the way the editorial board was working. The Transaction was the premier activity of the society, and that's why they put all this information dissemination committee, they called it, to make sure that every paper received very careful scrutiny and the quality, to maintain quality control. The result of that was, of course, caused a lot of become very critical of anything. So it took a long time to finally get the paper in good shape and so on. So the early days was very distilled. As a matter of fact, by the time the paper is out, it's really quite a lot of work went into it. And so sometime during that period, there were in the 70s, not the 70s, the 80s, trying to really a little bit open the process up to make sure the society be more open to other ideas, new things, and so on. For a long time, we were stuck on this LU, GE, H infinity, and so on. So the attempt is really trying to make it broader, and that's really when they organized the whole structure. For example, that's graded the tab, graded the various committees to avoid now having everything just centered in this little committee, which was the Information Dissemination Committee. For example, all technical committees at the time, early on, were associate editors, so really did nothing other than handling papers. While the organization was trying to create a technical activities board that look at new areas, look at application. That was always been something that haunting in society, how to do more with application than just publish more theorems. And society then, that's when it started also to make sure we do that better. Some people say, well, let's bypass the transaction and start a new one called the Control System Technology. But really it shouldn't be looked at that way. But I was president when we voted on the Control System Technology, was simply to allow both things to exist, because one is very good and provide the theory, the basic foundation, does have application, but the emphasis was on the theory, while the Control System Technology was supposed to try to cover broader aspects of applications. And I think this was a good decision, because if you look at the vitality of the both transactions, they're all doing very well, and they all have a lot of backlog of papers. They have a lot of people interested in publishing in them. As a matter of fact, the latest ranking and so on, both are highly ranked journals. One of the things that, and in addition, involvement of the society with AACC really is a good thing, because of the fact that AACC tend to bring all these other engineering disciplines who are involved in control, mechanical, civil, and chemical, process control, aerospace, and so on, to try to really cover the application in a broader sense and not just stick with the thing. And that's really why you have very nice complementary relation. We have the CDC and the ACC, and you have about enough overlap, but you have also enough differences, so you get to see a variety of activities that involves control. What is happening now, I think, is very critical, very important to try to outreach to new areas, because I've seen both at this conference and also at previous conferences more emphasis trying to do financial engineering control, involvement in financial engineering, control involvement in biotechnology or other areas that we haven't addressed before. Today's paper, talk, for example, by Don Tilbury, was great, to see how the involvement in this, the PLC controllers. So it's really, we are seeing the control society really expanding to try to really cover many more areas and be more relevant, not just on an archival basis, but also on today's problems.
We're going to come back to that in a minute, but I'm curious that were you editor when Control Systems magazine was?
Yes, the Control System magazine started about it started before I was editor, I think. And I was in the blog at the time when it started. And we used to have a newsletter, but the newsletter was very dry and very small, just not something you keep. So it was decided to have a magazine so that to apply to the rank and file members. Because, every member at the time used to get the transactions and the newsletter, but the transaction, as you know, is not readable by rank and file engineers. That's really was the impetus to start the Control System magazine. And Mojam Shidi, who was the first editor, really did a wonderful job trying to get papers that are readable by everyone, more address technology issue, describe society news, describe other control news, and it became really one of the top magazines in the field. And led eventually, only after all three publications became successful, that the society thought, let's unbundle so that you don't have force everybody to take all the transactions and the magazines. The magazines given membership fees, and the others are given for extra. And I don't think that many people really dropped either transaction simply because of the fact the quality is there and you would like to keep receiving those.
Did you interact with Herb Rausch much?
Yes, Herb Rausch was the second editor. I followed Mojam Shidi. So in fact, Herb Rausch followed me or 2 years later as president as well. It took a while to get him to relinquish the magazine so that he can go on and do more wonderful things for the society. But during his term as editor, really, the magazine really flourished and became much more successful.
So you remember him had a huge editor.
Yeah.
Let's talk about. I want to ask you about sort of the past and the future of the Control System Society, control in general as a field. What do you think our strengths and weaknesses are?
The strength of the control field is the fact that it's very solid. You have a lot of good people, strong people working in it, and make a lot of tremendous contributions in any area they can take. As a matter of fact, not only in terms of with application, not just to the control field, but if you look at department chairs, many department chairs who are former control society members. So it's really a very important area. The weakness, I would say, is the fact that the way it developed in academia, especially in the EE department, tend to be a little bit, to become more and more abstract and less application oriented. That's some of the fact that the reviewers for NSF, for example, who are funding this research, tend to be the same kind of people who review the papers. So you have sort of like a positive feedback. So you have the same kind of work get funded and get published, and you get very, very more and more abstract and distilled information. We tried to open that up with the appointment that was done in the 80s to appoint associate editor at large who were given the mandate to try to bring survey and tutorial, bring papers who are broader and not just the standard thing. And that really helped because, for example, I remember a paper written by Dr. Fingansas was very nice about aerospace control. There were papers dealing with Mike Athens about CQ. So we tried to really open the transaction to more, not just transaction, but the whole control field to really do more than just prove theorems. And that's really the thing that the strength, as I said, is the fact that it's very solid, but we need really to try to infuse it with some application or industrial interest or relevancies. And that, I guess, with the NSF move away with the centers and so on, stressing the need for industry collaboration, that is happening actually. You see that many places, for example, when I was at Georgia Tech, many control people were moving into working in manufacturing. If you look now, they have several control people who used to be very theoretical, working in centers, manufacturing centers. At Stanford, you find that at Illinois, you find that at Michigan, a lot of places. So it's really, we see the application really getting exciting control engineers to work in. We see that now with the communication network. And in fact, the transaction is having a special issue coming up very soon on control of communication networks. So we see broadening of the field, and that's really a positive step. And I think for a while, as I said, what made it really stuck on this thing was earlier method that was very, very, you have to distill every paper until you get it published. Now you see more openness and better responsiveness to application.
I'd like to follow on this because it seems that control, some people write in papers that perspective paper that it's a stealth technology, and it's in everything that really doesn't get a lot of credit. Controls engineers tend to be, if you look among the engineering profession, the lowest paid. If you graduated a couple of years ago during the internet bubble, you said you were a communication systems engineer, you probably make twice as much and have a lot.
But not now.
Not now, but it seems that. Why do you think that's because of the theoretical?
I think for a while there was a lot of emphasis on, again, very dry mathematical tools, which sometimes people who got the PhDs or whatever it is really didn't know even how to apply them. And that's really coming from, for a while, as many people wrote about this before, that we're sort of like the people who write their dissertation and work motivated by other dissertations rather than motivated by real problems. But the job market and other things work to balance. You have feedback, so it works in the sense that you see more people working in a variety of areas. Trying to control people now, working practically every area. You're right about the fact that the control doesn't get always the credit because, aircraft will not fly without the control engineers. Mm-hmm. But it's not visible, so that you don't see that in the thing. You look at they want to design the body, whatever the displays, whatever it is, but the control is behind the scene, and that's really one thing that many people in industry don't understand. But we see more, but control because of the way they are trained, in the sense, very problem solving. They really can apply in a variety of areas, and that really makes it actually more saleable in a way. If you really are willing to say, I'm not just working in H infinity, or I'm working on this. Can you find that now it's as broad as you can make it? And you can work in communication, you can work in signal processing, because, when you design digital control already, what is it? It's involving a lot of signal processing issues, involving computer engineering issues, how to implement it, and so on. So a lot of control, if we're willing to broaden, you have the fundamentals, because they're a very good foundation, a training foundation, and that's really the important thing to remember about control.
Do you feel that creates a brain drain on society, and we're training a lot of engineers who end up working in other fields?
And I'm not saying they're working in other fields. They're applying control to other applications area. Robotics. Robotics, 90% of the work is control. But we have the called separate society now in the IEEE. But still, many of the people are still members of the control society. It's through the publication they publish in different journals. But what they do, they're doing control in many cases. So it's really the same thing with communication and so on. So it's really very difficult to really try to, since the control society really is part of IEEE, so it shouldn't really be a matter of competition of, you are not here but you're there, but it's really more what the people are doing that's important. And more interdisciplinary work really is really what is called for in many of the engineering disciplines, not just electrical, not just control, but every place. Like you think that information technology is pervasive everywhere. You look at biomedical, you have control problems there, you have chemical problems, you have biological problems. But again, you have a lot of control engineering could do a lot of them. In fact, one of the papers for this workshop is coming up this Saturday dealing with this kind of problem.
What do you think some of the promising future directions for control research and education as well as practice and application?
Education, I guess I'm still a believer that you really have to do the standard basic control theory because it's really very strong educational tool. You learn a lot of stuff, and and feedback is something fundamental. It changes the structure of the system and so on. Whether you are, no matter what your field in the system side, system EE can divide into 3 areas: systems, computers, and physics, optics, and so on. But the control, as a matter of fact, now we have even interest to control into optics as well. So it's really, or controlling solid state manufacturing. I mean, this is something which is, it's a very fundamental problem in control. If you consider they're trying, when you do research with all MOCVDs and so on, creating all these devices generating these materials, when you try to put them back export them to the manufacturing production, you need very strict control. So this is something which the teaching control on a fundamental basis, it's as good as it is. What is important is to keep adding what you see now, a lot of laboratory example, because at one time some universities abolished their laboratories for control. I know when I was at Georgia Tech, they didn't have a lab in control, but they started it about 5 years or so after that, because they felt it's very important to have a laboratory in to really get people to feel what feedback does, how to design good feedback design, and so on. Now, what areas, to cover after that, what area to emphasize, what area to come, you cannot do it in one course. You have to really do digital, you have to do some adaptive. You have to be a combination of things, and it's really very difficult really to point just to one solution. You have to really see what else, because it's a very broad field. People are doing nonlinear control probably don't know much about stochastic control and vice versa. What areas, future, I would say, again, the future really would be in the applications, which area to look for. One of the key areas, I think, the hybrid system, and whatever it's called now, in this new, not the old way, just for a while, hybrid was, everybody called anything the more discrete or continuous, called it hybrid. But it's really, there are a lot of body of work dealing with hybrid systems like manufacturing or communication networks, and people like Sundress and Larry Ho and all this, and their students. They're working a lot. It's a very important area because it's really have a lot of applications. You find the areas of, there are too many applications for me to mention. They all involve control. The difference here is that now we don't have to look for everything or look for a closed form solution. You have to look for another, look for a process, look for a way of computing the solution rather than the old days that you have to come up with some solutions.
And do you see the same areas for applications and practice as for research, the communications?
Yeah, I believe so. But the main thing there is really have to get, I've seen people working, for example, in even places like Wall Street, financial engineering and so on. Or I've seen a very good paper recently about margin trading, whatever, in terms of power, buying power and so on and so forth. It's very important. It's a very interesting stochastic control problem. But so there is room for that. As a matter of fact, people in the control area are finding jobs in places like involving investment or stock trading.
I wanted to ask you about, sort of from your perspective, having seen a lot of things, do you think that the engineering field is addressing the issue of women in engineering, or doing a good job, or doing a poor job?
I think the universities are trying to do that because that's where it starts, where you're trying to get more women in engineering. Not just women, we're a minority, I would say. what is not being done properly, I think, in my opinion, that again, from empirical observation, is while the hiring is being done, women are hired and promotion, people are getting, people are recruiting women students to engineering and so on, to control specifically. When it comes to tenure and promotion, tenure committees tend to be still the same kind of mold, the old boy network kind of thing, and you find sometimes some very good women do not get tenure at some universities because of the promotion committee. Well, this is not the same thing. I give you an example. Like I know someone, for example, a woman have also that she was having some universities which shall remain nameless. The woman was pregnant and was told, well, you can have a year. Tenure clock will be halted for a year because of she has to leave, whatever it is, maternity leave. But obviously the promotion committee we're going to see as much production as if you didn't take the leave, which is it's very condescending, very poor planning and so on. Fortunately that woman did get tenure, but it's really this kind of attitude by male chairman or male committee chairs is not very conducive to women engineering. I was very pleased to see a lot of women engineers at this conference, by the way. The numbers keep increasing.
So, do you think that engineering firms are friendly places for women engineers?
I think so. Engineering firm, I think, more so simply because of all the equal employment or whatever it is. But universities tend to be, because nobody can really tell the tenure committee what to do. They tend to be a little bit more, is she doing exactly what we want to do? She have X number of papers in this Y journal, kind of thing, rather than doing a lot of different things. It's just the one. So the university is the only thing I can address because I really have more experience in universities. But they tend to be a little bit too demanding in terms of when a woman comes for tenure, then when a man comes for tenure.
So what about, you mentioned minorities in engineering?
That's a tougher question. It's very difficult really to address that. The number is small. It has to really start at the elementary school or high school level. Try to get people to apply to engineering and so on. Junior school has to be more open about what kind of thing they need to do. When I was chairman of Western One, I hired 2 black females as the faculty members. One of them just got to be promoted to full professor.
So I had a friend that went to grad school with her black female PhD from Stanford, and I remember when she finished, she was such a rare commodity that essentially it was like people were just coming in. But there seems to be by the time she'd gotten to that point, it seems like there wasn't. By then, it's almost too late.
You need to start at the elementary school. Get people involved. People have to go to the inner cities, schools, try to get people involved, interested in things. And that's really quite. You cannot just do it by fiat. You cannot do it by just at the upper level. It has to be started from the grassroots. It's a lot of work because really society has to really be accommodating to be as diverse in the upper in this field as it is in other fields.
Do you think that there's always been a perception of engineers in particular, probably not very friendly way, and at least for a while during the internet bubble, there was a little bit less of that. At least if you said you were working for .com. Do you think there are ways that the society or IEEE can address those types of image issues that might be keeping people away?
I don't know. The only way you address that is really many people. This is not a new. I mean, people have said you need something like LA engineer, like you have LA law and so on. I really don't know what engineering is. Still, basically, is very the image to outside to non-engineers is not very well understood. And it's just because since work is behind the scene, people don't see, they see the product and realize, well, engineering really has a hand in this. So it's very difficult really to do anything other than more education, make film, movies, or videos, and so on to educate the public. Some PBS programs. There's not, you need to have something to show. And some years ago, during the centennial year, '84, I think, I actually tried to do some videos. Was interesting at the time, but they didn't follow through with that. What happened after that? It'll be available for about a year or two.
I'm curious because during the past few years, there have been a lot of consumer appliances which advertise fuzzy logic control, and while I don't want to go into that particular area, it seems like those type of consumer appliances haven't drawn the attention of controls engineers, and so while a lot of people can tell you, oh, this washing machine has a fuzzy logic controller, it seems a shame that they're not telling you, oh, this has an H-infinity controller or whatever. Yeah. Do you see that as something that the controls community should try to address going into like these products that everybody sees?
I've seen it mostly in Europe and Japan and so on. I haven't seen it in this country too much of this fuzzy logic or other kind of appliances. People really don't look at appliances with what kind of engineering is in it. And that's, somehow people have things either work or doesn't work, and they don't really look at the technology or what great technology. That's unfortunately simply because our society tend to have a lot of educational system really. They don't get enough. There's not enough emphasis on science and engineering at the elementary and high school. That's something which, we had, I guess, Bozina organized a workshop, high school teacher, and trying to get control over other engineering and so on. A few years ago, it was in Chicago, right? So it's really important to try to get all the schools, to get the kids early, because they are eventually forming the public, and the moment they tend to be excited by a lot of things, but engineering somehow doesn't do the job of trying to excite them about engineering.
So you see that more as a global problem with engineering, not specifically.
That's right, global problem with engineering, because you don't see that in any engineering discipline that they have similar problems. You don't see that with doctors, you don't see that with lawyers, but with engineers, it's very common.
So as we're running out of questions here, but as we wrap up, do you see what do you think the next 10 years holds for controls engineers in particular, but engineering in general? What do you expect to see? What do you think we should be doing? This is sort of a very open-ended question. If you want a soapbox or something, feel free.
Well, what we are doing really seems to be, we are moving in the right direction. I see both, I'm on the editorial board of transactions, and I see the way we are trying to do, looking at new special issues. With ACC, for example, I see what kind of thing we are looking for, new avenues to really look into control and so on. So control really is always a very dynamic profession, and it's really that's a strength as well, if I can say. So it's really difficult for me to say which area we should go into or not go into, because the spectrum is very broad. As I said, there are people working on optical systems, people working in communication. There's a lot of new areas that can get into. The key area of all this is solid state, for example, nanotechnology and so on. Control has a lot of role to play, because you have to really, you cannot just do it by relying on the physicists, because you need to get feedback in there to make sure whatever you do would be produced to the right quality. And that you cannot do without control. And society, I say, the young people in society are great, and I think it's in good hands.
Did you want to ask about the early years of early school, or
we sort of went through that.
Past that, okay.